Hey everybody, hope you guys are doing great today. We're going to go ahead and jump in, continuing on with truth tables. So remember last week we talked about truth tables, we introduced truth tables as a way for trying to understand when is it that our sentences are true and false. Remember that's going to be a really important part of this. What we're interested in general in this class is trying to understand when our inferences are good, right? I want to keep repeating this. And one way in which we can understand our inferences are good is this idea of validity, is this idea that, well, hey, if I have an argument where it's impossible for my premises to be true and the conclusion false, well, then that would be a good inference, right? If I know that having true premises would guarantee that my conclusion is also true, that would be a good argument, right? That would be something that says, hey, these premises actually entail the conclusion. The conclusion follows from my reasons, right? So that's what we're after. We're trying to figure out when is it that a conclusion is going to follow from reasons? When is it that the reasons or the premises are enough to justify the conclusion? And so to understand this, we've been looking at, right, we've been building up this formal language. We spent a few weeks talking about that. And then we started trying to, okay, now that we have these things written in our clean formal language, how do we actually understand when these complicated statements are true and when are they false, right? And the idea of a truth table was simply just to try to break down all of the possible ways in which these various situations could go, right? So if I'm going to be talking about two things like G and B, like my car's tank has gas and its battery has a charge, right? Then there's four possibilities, right? Either I have both gas and a charge, I have gas but no charge, I don't have gas but I do have a charge, or I have neither gas nor a charge, right? There's four possibilities. And the idea was, as we start adding more sentences to that, right? Like maybe we want to talk about, okay, but does the car start, right? We're going to continue to add more and more possible things that could happen, and likewise right? There's going to be more possible worlds, right? There's more possible complications, more combinations of each of these individual statements. And one thing that we could do with this then was we were able to try to categorize these things into these sorts of categories. Right? So, as we saw at the very end last time, some statements are true no matter how the world goes. Oops. Right? So, like if I said, hey, either Santa Claus exists or Santa doesn't exist, right? Like it doesn't matter how the world actually turns out, I'm right either way, right? So, there's some things that we call them tautologies. A lot of times, a lot of philosophers will think of math as tautologies, right? Like when I say 1 plus 1 equals 2, that's not just true in this world, but if things turned out differently, then, hey, 1 plus 1 doesn't equal 2 anymore, right? This is just always and necessarily going to be true. On the complete flip side are impossibilities, right? These things that are just never true, right? So if I said, hey, Santa both exists and doesn't exist right now, right? Like there's no way I'm right. Because either Santa exists, in which case I was wrong to say that he doesn't exist, or Santa doesn't exist, in which case I was wrong to say that he does. But like I should never say just both things at once, right? Similarly, right, if I try to say, if we go back to modus ponens up here, we can think about other contradictions. If I say, oh, I believe that A would lead to B, and I believe that A is true, but I don't believe that B is true, right? So I haven't formulated that in a sentence, but there's certain things that we could see, no matter how the world goes, I'm not going to be able to, right? Some statements are just not going to be able to be true. So going back to our math example, right? Like 1 plus 1 equals 3, that's just impossible, right? It's not that like, oh, well, let's wait to see how the world goes to see if 1 plus 1 equals 3. It's just an impossibility. Okay. On the other hand, right, and we could also think about possibilities, not impossibilities, but possibilities. So if impossibilities are you're never true in any possible world, possibilities are things that are true in at least one possible world, right? So that's what a lot of the sentences we were dealing with last time. So like the sentence, Santa exists, is not a tautology. It's also not impossible, but it is possible, right? In some possible worlds, maybe Santa exists, right? But in other worlds, Santa doesn't exist. Okay. All this is just recap to remind you what we can do with our truth tables, right? This idea that we can think about all of the various ways in which a sentence could be true or false, and then we can compare those to other sentences, right? In what situations are you true versus in what situations is this other sentence true? And that's going to be part of what we're interested in today. So today we are going to work our way up to comparing statements. But before we do that, we need to add in our other two connectives and also rehearse a little bit about how do we do these truth tables in the first place. Because one thing about this is sometimes, especially when we're trying to put these out in a whiteboard, it can just get bloated and confusing. So first of all, if you're feeling that, like, hopefully you don't right, like that's not you. That's truth tables themselves can just be difficult to get into early on. It's a really good idea to be spending your mental energy here in terms of like a logic course, trying to really get good at truth tables because of how impactful they will be later on. But it's okay if it takes you a little bit of time to do so, and just know that it is a good investment to be focusing on this unit. Okay, so let's think about this. So, right, with a truth table, the idea is we think about we have a specific statement, and then we want to think about all of the possible ways that the world could go with regards to its atomic sentences, right? So in this case, we have a statement that says, well, if it's raining, then the ground will be wet, right? And so the idea is we want to think, okay, so this statement is talking about it raining and the ground being wet. So whatever the atomic statements are, that's what tells us what our reference columns will be. And then what we did was we just laid out all the possible worlds with regards to those two statements, right? There's the possible world where it's raining without the ground being wet. There's the world where it rains, or excuse me, I messed up the first one up. The world where it rains and the ground is wet. World where it rains and the ground is not wet. The world where it doesn't rain but the ground is wet. And the world where it is it doesn't rain and the ground is not wet. Right? And so all that I'm doing is this is the same setup that we do every time. We just try to find what are the four possible combinations of these two statements. Right? And so this setup, right, is going to be you're going to get very used to this. If you have one statement, you have just T and F. If you have two statements, then you have two columns. You have TF, TF, and then TT, FF. And then when we have four statements, we double this again, etc., etc. Okay. So now what we want to do is we want to think. Last time we looked at this, we were doing the same sort of thing. And we looked at and. We also looked at or and negation. Right? So last time we looked into, all right, if my left side is true and my right side is false, and it's an or statement, I'm still going to call it true. Or if my left side is true and my right side is false and I'm trying to build an and statement, I'm going to call it false, right? So we looked at how to understand and work with these three first connectives. But what we didn't do was our other two connectives, right? Our two conditional connectives. So that's what we want to build in now here. So let's think about this. Let's think about in each of these possible worlds. And at this point, we're just intuition pumping. What do we think the truth value of this statement is going to be? Okay, so let's think. Suppose that it's raining and it's wet outside, right? Do we want to say, so here, actually, maybe a different way to, yeah, I think a more intuitive example, actually, will be this one. Let's say you get let's say. So I actually want to, let's just switch this example just slightly. Just because I think this example is going to be helpful for us to pump our intuitions a little bit better, and then we'll apply it to the one we have right over there. So don't worry, we haven't forgotten about rain and wetness. We're just going to, let's first think about this in terms of tests and classes and stuff like that, because I think this can help us just make this come much more apparent. So let's say I made you this promise that if you get an A on your final exam, then you get an A in the class. Suppose I were to make you this promise. What I want to know is under what conditions would we say this is a lie? Okay? So actually, let me write that out a bit. So, suppose I promised you that E implies C, right? Which just means that if you get an A on the exam, then you get an A in the class. Okay. So what I want to know then is, under what conditions would you say I broke my promise? Now, to be clear, I am not promising this. But under what conditions would we say that this promise was broken? Right? So let's say in Possible World 1, you got an A. You got an A on the exam, and you got an A in the class. Right? Would you come back to me telling me, hey, Sean, you're a liar? Right? No, of course not. Right? I would be really confused if you came back, because I would say, wait, you got an A in the class, right? And you got an A in the test. So yeah, I told you if you got an A on the test, then you'd give you an A in the class. So obviously, you got an A in the class. I didn't lie about anything. Right? Again, at this stage, we're just kind of like trying to pump the intuitions about this connective. Let's bump down maybe to the end. Suppose in Possible World 4, you did not get an A on the exam. And, of course, I did not give you an A in the class. Well, you wouldn't say I lied, right? It's still a true promise, right? So even if you didn't get an A on the exam and you didn't get an A in the course, that doesn't mean that the rule wasn't followed, right? All I was saying is if you did get an A on the exam, I'd give you an A in the course. But if you don't get an A in the exam, then, hey, I don't know if you'll get an A in the course. Right? How about this third world? Suppose you didn't get an A on the exam, but you still got an A in the course. Would you say I lied? Well, no, of course not, right? Because I didn't say the only way to get an A in the class is if you get an A on the exam, right? You might have done amazing everywhere else, gotten an 89 on the exam, and then you say, oh, well, shoot, right? You still deserve that A in the course. So you, again, wouldn't say I lied. The only way you would ever say that right, that this is not a true promise, that I didn't fulfill my promise, is if you in fact did get an A on the exam, but then it turned around and you didn't get an A in the course. That would be the only time we would say that's a false statement up here. Right? That's the only time we would say that, hey, that rule wasn't actually followed. Right, so let's review that, because there's a reason why we saved this connective for today, and not just burying it in with when we were learning truth tables in the first place. It's because this one is kind of counterintuitive, and it's also not symmetric. Right, this arrow is pointing in one way, and that actually makes a big difference. Right, we're saying that E implies C, and so what that means is if E is true, C better be true too. So the only time this statement is false is if C turns out to be true, or E turns out to be true, but C doesn't also turn out to be true. But if E is false and C is true, like this statement, that's still okay. Right? So this is the really counterintuitive one, right? That even if it's false, the left side, and it's true, the right side, or both sides are false, we're going to call the conditional true. The only time we'll ever call a conditional false is if the left side is true and the right side is false. Because that's essentially what we mean by this conditional. We're just trying to say, hey, if this were ever true, then the right side would have to be true. So the way for that to fail is if the left side can be true, but the right side really does turn out to be false. That would mean this promise, this rule, doesn't actually hold, right? If we live in a world where you did get an A on the exam and you did not get an A in the class, then it would be false to say getting an A on the exam entails getting an A in the class. Now it's the only world where we can say that. So then let's think about this. Let's just do, right, we're going to do the same thing over here. All we're going to say is the only time it's wrong to say, so this statement is saying if it's raining, then the ground is wet. The only time it would be wrong to say that, or maybe put it another way, what would make that false is if it's really raining, but the ground is not wet. Right? That's what it means for that statement to be false. But if it's raining and the ground is wet, then we're going to say that conditional is true. If it's not raining and the ground is wet, that still doesn't mean the conditional's false, right? Maybe somebody sprayed it with a hose or a sprinkler or whatever, right? But that doesn't mean the conditional is false. If it were raining, then it would be wet. That's still true. And similarly, even if it's not raining and it's not wet on the ground, that doesn't mean the conditional still isn't true. Right? If it were raining, then it would be wet. So again, with conditionals in general, this is the row you want to be thinking about. Let me even just wrap it up. Right? This is the only time a conditional is false, is in the second world here, right? Or whatever world it'll occur in your truth table, where the left side is true and the right side is false. And what I mean by that is, right, as we're going to be doing this, as you've seen, sometimes, right, what counts as your left side is really a subformula, and it's, right, in a placement that might not always intuitively correspond to left and right. But all of that, we'll be getting more comfortable with it as we do more examples. Okay, so that's what a conditional is. So as we move down here, we're adding more to our tool belt. Right? So we have our negation. Remember, the negation just says whatever you're attacking that negation onto, I'm just going to flip the value. So if you were negating a true statement, then the negated statement is now false. If you were negating a false statement, then the negation is true. It was right to reject that false thing. For ors, right? So for each of these, we can just essentially think about one special row. For an or, the only time the or is false is if both sides are false. Ands are essentially the flip of that, right? The only time an and is true is when both sides are true. And then the conditional is its own weird case. The only time a conditional statement is ever false is if the left side is true, but the right side isn't. Because again, and I can't emphasize this enough, that's exactly what the conditional is trying to rule out. The conditional is trying to say, hey, you'll never have a true left and a false right-hand side. And so if we actually find ourselves in that world, well then it's false to make that conditional claim. Okay, so let's go ahead and continue on, because we have one more connective we haven't looked at, right? And that's the biconditional. And once we finish up with building out these foundational canonical truth tables, we'll start looking at some examples. But again, let's just try to pump our intuitions. What do we think makes sense here? And again, I just want to continuously reiterate this. As we go, right, we don't want to rely on just what makes sense intuitively. We're going to be relying on these foundational truth tables we're building up right now. So we're using our intuitions to kind of explore what these are. But once we have these truth tables right here in front of us, again, these are going to be, actually, I should really be labeling these as the foundational truth tables. Once we have these, we're going to set aside our intuition and set aside that sort of thing, and we're just going to be bouncing back to these guys telling us the rules to follow. But right now we're just building up our intuitions to see what these are supposed to be, to convince you that they make sense, if nothing else. So, okay, let's think about this statement. N if and only if D, right? So remember this double arrow here. It's trying to say that if N were true, then D would be true. And if D were true, then N would be true. So like one way to think about this, maybe I'll just translate real quick right here, is this is say n if and only if D is saying Nancy goes to the dance if, when, and only when not Nancy, Daphne does. Right? That's what this statement is saying. Right? This is just comes back from our translation days up here. So, where am I? So, right, we want to try to think, okay, so this statement is saying Niles and Daphne only go to the dance together or they don't go at all, basically. So we want to think in what, here are the four possible worlds. In what world is it true to make this claim that Niles goes if and only if Daphne does? Right? So, okay, let's just run through it. Suppose you see Niles and Daphne at the dance. Are you going to say it's wrong that Niles only goes if and only if Daphne does? Well, no, right? Like you would say, hey, okay, yeah. In this world, I'm not going to reject that. Now, and suppose instead, in World 2, you see Niles at the dance, but you do not see Daphne. Well, then you would say, no, it's wrong to say Niles goes only when Daphne does. Maybe it's true he goes when Daphne does, but he doesn't only go when Daphne does. Apparently he's going in other times, right? Like even when Daphne's not there. So in this second world where Niles goes but Daphne doesn't, it's wrong to say Niles goes if and only if Daphne does. How about in the third world, right? Here unlike the regular conditional where it's a one-way arrow, it's a two-way arrow, right? So we have essentially the same thing going on. Suppose you see Daphne at the dance without Niles. Well, then it would be wrong to say that Niles goes to the dance when Daphne does, right? Because Daphne's here and Niles isn't, so Niles doesn't go when Daphne does, so that one is also false. Now, suppose we don't see either one of them there. Well, now we're not breaking the rule. We're saying Niles goes when Daphne does, and Daphne goes when Niles does, but if Daphne didn't go, and Niles didn't go, then neither one of them had a reason to go. Right? So this is like saying that they're always together. Either you're going to see them together or you're not going to see them together, but you're not going to see one and not the other. That's what this biconditional is really saying, is that these guys essentially have the same truth value. Right? If one of them's true, the other one's got to be true. If one of them's false, the other one's got to be false. That's what we mean by the biconditional. So it's really important to see the difference, and we'll be looking at the relationship more and more as we go, between the conditional on one hand, which says if one thing was true, I know the other's true, but with the conditional, I don't know that, like, it doesn't tell me that the right-hand side entails the left-hand side. Right? Just because I know W is true doesn't mean I know anything about R being true. But the biconditional adds that too, right? The biconditional is saying N implies D and D implies N, right? So that's why we have this symmetric pattern here. And that's what gives us our final of the canonical or the foundational truth tables, right? So now we have our negation, which just flips the values. We have our disjunction, which is always true unless both sides are false. Our conjunction, which is always false unless both sides are true. The conditional is true unless the left side is true and the right side is false. And the biconditional is true unless the two sides just disagree on their truth value. Right? The biconditional is true anytime they both have the same truth value. Okay, so all of this is meant to try to pump our intuitions for how do we get to what we think these sorts of things are. But what I want to do now is I want to start thinking about, all right, let's do some actual examples and get to see this in a better, more clear way. Okay. So since last time I went ahead and made this little app, web app, to help you guys see this a little bit more clearly. Because I think sometimes when we're doing this, like just on a whiteboard or a piece of paper or whatever, it can be difficult to be thinking like, okay, so what am I supposed to be looking at any given time? So what I want to do now is just dig into some examples. Now we have all of our connectives, just kind of like think about these as in our tool belt, right? So I'm leaving these canonical truth tables here as just essentially sitting in our tool belt, and we're going to be referencing over there as we need to. But what I want you to be thinking about is just where to be looking at the right times, or at what times. So in this app, so I'm just going to be going through a handful of examples, and hopefully the visualizations in here are going to just help you see, where you should be thinking. Anyway, so the idea here is on the right-hand side. So let's say I'm trying to figure out when is this statement going to be true, right? I have this statement, if A is true, then B and C are both true, right? A alone entails B and C, right? So we want to figure out under what circumstances is this going to be true? And by circumstances, again, right, what we really mean is under what truth values, what are the possible combinations of A, B, and C that are going to lead to this thing being true, and what are the combinations of A, B, and C that are going to lead to this thing being false? So what we can do is we can just start off, right? So I'll try to do this in different ways for a handful of different examples, just to like continue to try to help you see what's really going on here. But like one way we could start is we could try to think like, okay, so what we need is all of the possible combinations of A, B, and C. So, well, I could think about, well, there's C. I could have that as true. I could also have C as being false. And both of these, right, could happen while B is true. And both of these could happen while B is false. Right? So right here I have all four possible combinations of B and C. But of course, all of this could happen while T is true, or while A is true, and all of these could happen while A is false. So I want you to get comfortable with building this out. It's not just a trivial thing or like mindless work. There's a if you're not thinking about that as super easy, it's because you must be missing the pattern going on here, right? But like the idea is in the first row or the first column, we have just 1 by 1. Second column, we have 2 by 2. Third column, we have 4 by 4. If we had a fourth column, right, if we had a fourth atomic letter, we'd have 8 by 8. We'd have all of this for that being true, and then we just double it, right? We would just copy and paste all of that, put it below for that fourth letter being false too, right? So you'd have that fourth letter for all of these 8 cases being true, or fourth letter being true for all of these 8 combinations, and the fourth letter being false for all of these 8 combinations. You had a fifth letter. Well, now you have 16 combinations to double up, and right, we're going to double every time. Okay, anyway. So now when I jump over here and I say, okay, so in world 1, is this thing true? So what you might have already noticed, the program immediately gives you this extra column here. Because the idea is the truth value of this thing, of if A, then B and C, it depends on 2 different things. Right, on the left-hand side, on the red part, it depends on A. But on the right-hand side, right, the green part, it depends on B and C. So, right, trying to figure out the value of if A then B depends on, or if A then B and C depends on A on the left and B and C on the right. So, right, that's the point of this program, right, is it's trying to help you see, okay, when I'm interested in solving the purple region, I need to look to the left-hand side in the red box and think about the green box as my right-hand side. And then what I'm going to do is I'm going to look over at my truth table and I'm going to figure out what I need to do. Now, in this case, right, like, hey, this B and C hasn't actually been filled in. Right, so really what I need to do is I need to click B and C. I need to figure out, is B and C actually true? But B and C depends on, well, right, B on the left and C on the right. So now I can finally get started, right? I can say, okay, I got B on the left, I got C on the right, and when I look over here, right, when I look at my conjunction truth table, it says if you have your true left and a true right, then you should say true. So I'll say true there. And now over here I can say, okay, cool. Now I've got I've got a true on the left, I got a true on the right, and I'm looking at a conditional. Right? That's the thing that's pulsating. So you'll notice the thing that's like glowing there is the connective that you want to be looking for over here, right? On your little tool belt. So the idea is we click a box, and when we click a box, it tells us what connective do we want to be thinking about. So I'm going to look over here and I'm going to say, okay, I care about this rule. And then I want to say, okay, and then the left part is the red box. So that's true. The right part is the green box, so that's true. So I say, okay, looks like we're in world 1 then. Right? We have a true on the left, a true on the right, and so that means I'm going to say the conditional itself is true. Right? And now I'm going to just continue to do that same thing. I'm going to say, okay, so suppose I want to figure out, is this big sentence true in the next world? Well, again, it depends on B and C, so I need to figure out B and C first. So here I look, okay, B and C, I care about a conjunction, right? On the left, it's true. On the right, it's false. So then I'm going to say this has to be false, right? Because when I look over at the conjunction rule, I see, well, the only time it's ever going to be true is when I have both truths. So then I go that. So really, at certain times. So as you're doing this, you'll start to realize different knacks for trying to do this more quickly or various ways. We can do just row by row. But another way we could do this is just thinking, okay, let's figure out in each of these possible worlds, is B and C true? Right? So in this world, B and C is false because we don't have both. False because we don't have both. True because we do have both. Let me make sure you can actually see this. Right, true because I do have both. Here, false. Here, it's false. Here, it's false. And right, I can also check my work and see, oh, I did make some sort of mistake. Oh, so it's telling me, yeah, okay. So it's telling me my columns themselves, it doesn't like how I've filled those out. Okay, so this is a bug in the program. So I had this essentially just flipped. So they didn't like that I had it flipped. This is just a bug in the program. I will need to fix hopefully before any of you actually use this. So I was doing TTTT FFFF. Generally speaking, this is a good point, I guess, a good pedagogical moment. It doesn't really matter which order we write these columns in. Now, it's like in the sense that like there's no being the first possible world doesn't really mean anything, right? It's good to do it still in this like 1x1 pattern, 2x2 pattern, 4x4 pattern. That way you know you're not making a mistake. If you try to just like think about each and every combination and list them off, like that's just asking for errors. The only difference is instead of doing T, F, etc., and F, like starting with truths and going to falses, they're doing the reverse. So it's the same sort of thing, or same exact thing, just right, they're just doing it reverse. So okay, well, we've filled our reference columns. So now these would these would also have to flip. So now I have FF, FF. Good. Okay, and now let's just delete that for now. And now let's check our work. And now we're good. Okay. All right. So that's where we are now, right? We figured out in each of these possible worlds, here's the value of B and C. And now I can turn over. Now I can look at, all right, so there's another. Okay, cool. Got the highlighting off. So now I can come over and I can actually figure out, all right, is this conditional statement true and in which world, right? So in the first world, and now I'm going to think back. So now I'm looking at a conditional. So I'm going to go over to my conditional rule. So in the first world, right, I have false on the left, true on the right. or false on the left, false on the left, excuse me. So I say false on the left, false on the right. Well, my rule book says that should be a true statement, right? If you both failed the exam and failed the class, it's not wrong to say if you passed the test, you would have passed the class, right? It's still a true promise, even if both of the things happen to be false. Okay, so next one, false on the left, false on the right. Again, still true. False on the left, false on the right, still true. False on the left, true on the right, right? And here's where it's really important that we're picking out which one's the left, which one's the right. Because when we have false on the left, true on the right, we're still going to say the conditional itself is true. Oh, I'm blocking you guys off a little bit again. Right? So we're still going to call that true. Here, we have true on the left, but false on the right. Right? So we're saying it's true that, like, A is true, but no, B and C are not true. Well, then it's false to say that A leads to B and C, right? All that I'm doing is I'm thinking it through again, but really we're just pointing back to the same rule book, right? I have a true on the left, false on the right. Then I'm going to call the conditional false. So right, throughout all of these occurrences, this is the first time I've called the conditional false, and that's because the left side was true and the right side was false. That's the only time we'll ever call the conditional false. Okay, continuing on, another true on the left, false on the right, so it's a false implication. False implication, true. Okay, and we can check our work again, make sure we're sane, we're good. So just click fill reference columns, which seems to clear that highlight. Okay, so that is the complete truth table for this statement, right? So the idea is now what we can do is we can say, okay, this column right here, these values, this tells me exactly when this big complicated statement is going to be true and when it's going to be false. When A, B, and C are all false, this is still a true thing to say. When A is false and B is false, but C is true, the conditional is still true. Right? The only time I'm going to call it true is if A is true, but B and C are both false, or A is true and B is false, but not C, or A is true, right? So the only time I'm going to call this thing false is if A is true, but I don't have both B and C, right? That's what's going on in these three rows, which of course my head is blocking yet again, right? In these three rows right here, 1, 2, and 3, I have A being true, but I don't have B and C together. That's why this thing turns out to be false. Okay, so again, let's just keep going through more examples, and hopefully the more that we do this, the more this can start sinking in. All right. So let's go ahead and we'll just do another, I'll just start going through more. So I'm going to just fill the reference columns automatically, right? And so now I can think, okay, I need to figure out, right, when is this thing going to be true? So I can click in and I can say, okay, so deciding whether or not if A or B then C is true depends on figuring out, is A or B true? And is C true? Right? So, but in this case, again, like, oh, well, shoot, I need to figure out the red part first, right? Like, I can never solve a purple thing if I have a blank spot where it's pointing, right? The only way to solve, to answer these questions is if I actually know the values of what I'm looking at. So that's why, all right, I need to figure out the red blank first. So I click in the red blank and I see, oh, okay, cool. This is just an OR statement whose left side is A and whose right side is B. So I'm just going to use the OR rule. And I'm going to say, okay, I'm only ever going to call this false if both sides are false. And so, look, hey, here, look, both of them are false, so I'm going to call it false. Here, both are false, I'll call it false. One is true, so I'll call it true. One is true, I'll call it true. One is true. One is true. Both are true. Again, still makes my rule happy. Both are true. So the only time I said A or B was false is in the first two worlds here, right? Where I neither have A nor do I have B. So now I can look over here and I can say, okay, so when is this conditional going to be true? Its left-hand side So let's be careful here. You might be thinking, oh, its left-hand side is the C, right? Because that's on the left. No, right? Look at where C actually occurs in the formula, and we have it color-coded here too, right? C is the right-hand side. A or B is the left-hand side. So now I'm looking at a conditional, right? That's the thing that's pulsing. So I say, okay, the only time I'm ever going to call this false, though, is if I have a true on the left and a false on the right. Here I have a false and a false, so I'm going to just call this true. True on the left, false on the right? No. Right? This true, this C is on the right-hand side. This is the main reason why I've built this thing with all this highlighting, to like help you like look at the right things, because otherwise I'm just saying it, and sometimes that helps a lot of people, but not all of the people. So, right, the idea is I have this conditional, left-hand side is a false, right-hand side is a true. I'm not misspeaking there. This is the right-hand side. And so if the left-hand side is a false, right-hand side is a true, I'm going to call my conditional true. Here, the reverse, right? Left-hand side, the red part is true. Right-hand side, the green part is false. So now we have a true left, false right. We can call that false. True and true makes a true. True left, false right makes a false. True and true makes a true. True left, false right makes a false. True left, true right makes a true. And so now I'll go ahead and check my work, make sure I'm doing good. Okay. So as we're going through these, right, all that I'm doing every single, like, the thing about truth tables, that if you get hung up about them, it's because they just feel intimidating, right? Like, it feels like there's just like, oh, there's all these symbols going on and like all this technical language, and like that is very real. But like the thing to recognize to allow yourself to get past that and to make this just easy work is just to slow it down, right? And just do very, very simple things every time. That's really the point of a truth table. When people, like, the real risk with these sorts of things is people will try to digest all of the symbols at once, right? You'll try to think like, oh, there's an or and an and a this and a that and this, and like, well, how do all these things complicate each other? The point of these truth tables is to slow that way down and just say, look at one symbol at a time. Look at one question at a time. And then, through just this very slow, patient process, then we'll figure out, all right, when is this thing true and when is this thing false? Okay, before going on to the next example, let's remind ourselves, right? We had this question, tautology, possibility, impossibility, right? What do we think this statement is? Do we think this statement is impossible? Do we think it's a tautology? Do we think it's possible? So in this case, right, tautologies are the things that are always true. So this is not a tautology, because there are worlds where it turns out false, and tautologies are true in literally every single world. It's also not impossible, because there are some cases where it's true. It's not false in every possible world. So in this case, we call it a possibility, but not a tautology, right? It is a thing that could happen, but it's not guaranteed to happen. Another word for this is contingent, right? Depending on how things go, it will be true, but depending on how other things go, it might be false, right? Or how those same things go, it might be false. So we want to think about this statement and the statement we just did a moment ago as a possibility, right? There are certain worlds where it's true, certain worlds where it's false. Okay, let's do another example before we look at another couple of things. Okay. Yeah, let's do a nice big one. All right. And by big, we don't have too many rows, and hopefully, like at this point, you should be able starting to see. Do you see why we only have 4 rows in this table? Well, it's because we only have 2 atomic statements. right? We only have 2 reference columns. And the reason why we only have 2 reference columns is because there's only 2 atomic statements in this sentence, right? So 1 atomic statement means 2 rows, true and false. 2 atomic statements means 4 rows. 3, 8, right, all the way to your giant powers of 2. Okay, so the idea is, right, we want to, like, the truth value of this big, complicated, ugly statement depends on the truth value of A and B. And there are 4 possible combinations of truth values of A and B. So let's fill those in real quick, right? We have both of them being false. We have both of them being true. We have 1 false, 1 true, 1 true, 1 false. And then, right, we can think, okay, so let's just figure it out. If I want to know the truth value of the big sentence, right, its main connective is this biconditional, right? That's why it's the one pulsating. So when I go to solve this, what I'm going to be doing is I'm going to be thinking like, okay, let's go back to our biconditional. But the thing is, before I can even work on that biconditional's value, I have blanks over there. So I need to click my blanks. I need to figure out, okay, so wait a second. When is A and B actually true? Or, excuse me. So if I'm over here, let me take that away first. Let's take that away too. Right? I'm over here and I say, hey, I want to know what's the truth value of this statement. And I know, okay, it's going to depend on the left side, not A and B, and the right side, either not A or not B. Right? I just have my main operator, the biconditional, and then I have my left side and I have my right side. And so I need to figure out, I need to do both of those things first before I can do the purple. So I'm going to click my not A and B. And when I click not A and B, it says, oh, well, if you want to figure that out, it doesn't just depend on, it's not directly depending on A and B yet, because it's a negation. To know that not A and B is true depends on whether you know, is A and B itself true, right? Because we're just going to flip that. So I need to figure out, okay, is this thing true first? And A and B, of course, just depends on these guys, right? So it's false there. That's going to make that guy true, right? If A and B is false, then not A and B is true, right? And now, can I do this? Well, shoot, I've got my left-hand side's truth value, but I still need my right-hand side's truth value. So I need to come in here, and I need to do my right-hand side's truth value. Real quick, before I do that, I just want to re-emphasize, because this is just a classic thing that people will mistake. Some of you might have been confused when I put true here, because you're like, wait a second. Okay, you have a false there, but isn't A false and B false? Like, how do we do? But that, you're trying to do too much at once. Again, you really need to only think about one thing at a time. All you need to be thinking about with a negation is just, okay, what is the truth value of the singular thing I'm applying it to? Not, how did that thing get its truth values, way long ago? But what is the truth value of just A and B? Just this unit of a sentence, right? And if it's false, then we're going to call not A and B true. Okay. So then, right, I look over here and I say, oh, if I want to do my biconditional, cool, I've got my left-hand side figured out, but I still need my right-hand side figured out. So now I'm going to look inside here. So knowing if either not A or not B is true, well, that depends not on just like A and B. Again, that's we're jumping steps. Knowing if either not A or not B is true depends on knowing, is not A true? Is not B true? And then I can figure this out, right? So now I need to go deeper. I need to say, okay, is not A true? Well, A is false, so not A is in fact true. What about B? B is false, so not B is in fact true, right? Because all the negation is doing is flipping those. So now I come over here. Now I can do my OR, because now I've filled in the actual operands, the actual left and right hand side. A is not the right side, the left side. B is not the right side. Not A is the left side. Not B is the right side. So that's what we want to be recognizing. So then I say, okay, I've got this OR statement. On the left is a true, on the right is a true, so that tells me, cool, I've got a true. Now I can finally do the big ugly statement, right? The big ugly statement, look, it's a biconditional. So that means I go to my biconditional and I say, okay, you're going to be true just so long as the two values on your left and right side agree with each other. And here I have a true on my left, a true on my right, so I say, yeah, you agree, you're true, right? And I can go ahead and I can check my work, and I can see that it's right. So that's like, so the reason why I'm choosing this example is to show you how these big sentences, right, they're nested operations, right? And when you're trying to figure out the value, you never want to think about two symbols at once. Right, this isn't like, again, the reason why I bring this up is because all the time somebody will just think like it's a matter of just outsmarting it or something like that, or like just being clever enough to do, and really, right, you're just building bad habits that, right, like however bad they are right now, they're just going to get you into worse and worse trouble as you go on, right? If you really want to get some sort of like expertise in this sort of stuff, you need to build in these important foundational skills. Okay, so again, I want to figure out my biconditional. It depends on the left and right side. Left side depends on that. That depends on, finally we get down there, right? The right-hand side depends on those, etc., etc. Okay, so let's maybe do this row by row. Sometimes I like to do, like as you've seen, a column at once because you can just focus in on just one operator at one time. But sometimes it's helpful just to see how it all connects across each time. So I'll do that for this time. So again, I have my biconditional, depends on the left-right side. The left side depends, right? Not A and B, depends on A and B. A and B depends on, well, A and B. That, I don't have two truths, so I'm going to call it false. So now I've got a false. I'm negating it. I'm going to call it true. Now I'm going to do the right-hand side of my biconditional. I say, okay, cool. That's going to depend on not A and not B. I don't know those yet, so I got to figure out A. That's true. B, that's false. So now I can do my OR. My OR, I have one true, so that makes it true. Zoom out so you can see all these rules. And also scoot over so you can see these things better. Okay, so right. Just make sure I'm not. Yep. Okay, cool. And then I can do right now. I have my biconditional. My biconditional just wants to know: do you have a true on the left, or do you have the same thing on the left and on the right? I do, so I call it true. Next, I say, okay, biconditional again just cares about the left-hand side. Left-hand side just cares about A and B. A and B cares, of course, about A and about B. It's false in this case because I don't have both of them being true, and it's an and. Then I negate that, so I just flip whatever I found over there. Over here, right, I have this OR. The OR is telling me, just making sure I did all that right. Yeah, okay. The OR is telling me, right, look at not A and look at not B. So I need to find out not A. Not A is going to be false because A is true. Not B is going to be true because A is false. So now I can do the OR because I have a false on the left, true on the right. I'm happy with a true. I look at the left, I look at the right, I look at my biconditional, and I say, oh, well, you agree? I'm again going to call you true. Okay, final row. Again, I care about my left-hand side, I care about my right-hand side. In order to do my left-hand side, I need to figure out, okay, if I need to figure out not A and B, I need to figure out A and B. If I need to figure out A and B, I need to look towards A and look towards B. They're both true, so I'm going to call that true. Now, negation of that is going to be false, because I'm just going to flip whatever this column is. I'm just flipping it right here. Now I can do the right-hand side of my biconditional, and I see, okay, cool. This is going to depend, again, on not A and not B. Not A is going to be false here. Not B is going to be false here. So over here, either a false thing or a false thing. Well, my OR says, hey, that's going to be false. So then I go over to my biconditional, and I look to the left, I look to the right, and I see, hey, you agree. You're both false at exactly the same time. So again, right, just like up here, we saw Niles and Daphne. We saw Niles and Daphne. We saw Niles and Daphne. We saw neither Niles nor Daphne. So again, we're only ever going to see them together. So it makes it true, right? They're both gone. the truth values agree. So we're again going to call that biconditional true. And then we're finished, right? So now the truth value of this statement, the value given by its main operator, right, is true in every possible world. So now when we look over here and we say, okay, so like what type of statement is this? This is what we call a tautology, right? It's not just possible. It is, so technically speaking, it is possible because it's true in at least one row. Everything that's a tautology is technically possible, but it's much stronger than that, right? It's true in literally every single row. Okay, so, and likewise, it's definitely not an impossibility, right? Because it's not false in every row, right? It's not even false in one row, right? It's true in every single. So we have a tautology. Okay, and we'll actually be talking about this one more as we go. This actually, if we read into it, makes a lot of intuitive sense. What we're saying is not A and B is essentially equivalent to, is always going to be true in exactly the same cases as either not A or not B. Right? So if I'm trying to judge, right? So here's one way we can think about this, actually. So let's go ahead and bring us back right over here. So if I'm trying to judge something, actually, yeah, let's just say it like this. Let's look at these two columns right here. Oops. Yeah, good. Okay, let's look at these two columns, right? The one for not A and B, and the one for either not A or not B. Notice these two columns, and this is essentially exactly what we're checking when we did the biconditional at the end. These two columns always agree. And I mean, that's why we called them true over here for the biconditional, because that's really what the biconditional is checking, is if they always agree. And when we say that two things always agree, we have a special name for that. We call those equivalent. Okay, the idea is that for two equivalent statements, what we're just saying is the truth values are always going to be the same thing. So to say two statements are equivalent is the same thing as saying one biconditional, the other is always true, right? Like, because that's what biconditional means. But like, what I really want to do is I want to unpack this maybe more intuitively, right? Like, you can see, hopefully, like, sure, the truth values of these statements, I'll even just go ahead and, so right, like, let's think about it like this. We've seen, sure, the truth value of not A and B is this, right? The only time not A and B is going to be true is if both A and B are true, essentially. And then the truth value of not A or not B is the same thing. The only time it's going to be false is if you do have A and B. So, right, like, this is what we mean by equivalence. We mean that they're saying the same thing. So, the reason why this is interesting is because sometimes people will think like, oh, not A and B, you might think like, not A and B, you might think, is this equal to, or is this the same thing as just saying not A and not B? And no is the answer. It's not the same at all. When I say not A and B, I'm saying it's not the case that both A and B are going to happen. And that's much different than saying A is not going to happen and B is not going to happen. Right? So let me just be clear here. No! Right? So let's think about it in terms of like a game, right? Like people playing, two teams playing a game against each other. If I say it's not the case that the aardvarks and the birds are going to win, right? I'm saying, so like this statement right here, this would be both teams will both teams win the game, right? And right, and you might think like, well, okay, like what I want to do is I want to say that's wrong, right? Like that both teams cannot win the game, right? Like that's how most games work. Even if you tie, that's not both teams winning. That's both teams not winning. That's both teams tying. So what we want to say is it's not the case that both teams win the game. And what that means is we're saying it's not the case that A and come on now. Just means that it's not the case that both teams will win the game. Or I shouldn't say will, I should change the tense. Now, that is not saying, I can't emphasize this enough. This is just a classic mistake for people to make, right? When I say it's not the case that A and B, I'm not saying A and B are both false. I'm just saying it's not the case that they're both true, right? And I mean, really, this is the whole point of the truth tables. Is it's hard, it's really confusing a lot of the times to try to like think about both symbols at once. But that's exactly why we do go to, right, our truth tables, right? When I want to know, yeah, is it true that not A and B? Well, I need to figure out, is it true that A and B is only going to be true in one time, and so not A and B, or not A and B is only going to be false in one time, right? The time where you have both A and B. But if you have A is true, or B, or A is false, or B is false, or both is false, then this is going to be a true statement here, right? So it's really common for people to think like, oh, I can distribute this negation like it's math, but it doesn't work like that. Instead, notice what this is the same thing as, not A and B. Well, we just showed you, right? Not A and B is the same thing as saying either not A or not B, right? Or. When I say that it's not the case that both will win, that's just the same thing as saying either one will lose or the other will lose, right? I'm not even necessarily telling you one of them will win. I'm just saying it's not the case that both of them will win, right? These might be two teams in, right, like I might be talking about the Super Bowl, and these are two teams in a big 32 team league, and like I'm trying to tell you that both of them can't win the Super Bowl, but that's still short of saying that either one of them will win the Super Bowl. All that not A and B is saying is that I'm just rejecting the idea that both of them will do it. So again, all of this is, if nothing else, well, first, to give you an idea of how, right, you really need to, you want to slow down when you're thinking about how to interpret these connections, right? And this is what the truth tables could really help us do. That this is not saying both of these are false. It's saying that it's not the case both are true, and those are very different things. So like we started with the very beginning, a lot of this, right, it might be counterintuitive when you first encounter it, but right, it just takes some time to internalize what's going on here. So when I say that it's not the case that both A and B, that's the same thing as saying either not A or not B. So it's like when I distribute that negation, sure, you put it on the A and the B, but we also, you might think about it as you distribute it to the conjunction too, and it doesn't make too much clean sense, but you just think about it as, well, you change that conjunction to an or. And then notice though, we can ask the same sorts of questions with a similar set of statements, right? We can ask, okay, what about not A or B like this? Right? Here I'm saying it's not the case that either the aardvarks or the birds will win. So this is in fact equivalent, and we can verify this with our truth tables to saying, well, in fact, really, that's what I should do for you. Not A and not B. Okay, so I'll put these two next to each other so you can compare. Okay. And so, like, again, we can go into our truth tables and actually verify this, right? We like, the idea is we just want to try to verify, all right, when is it that not A or B is true? And when is it that not A and not B is true? So let's go ahead and jump over to our truth tables, and we'll do exactly those, right? We'll say, okay, so let's first just remind myself, not A or B. So do we have that as one of our, yep, we have our pre-made example. So I'll go ahead and fill in our reference columns. And then I'll say, okay, let's just work through this real fast. So it's not the case that A or B. So that's going to depend on A or B. A or B is going to depend on A. It's going to depend on B. It's an or, so it's false because I have two falses on either side. Here I have a true, I'm happy. Here I have a true on one side, I'm happy. Here I have two trues, so I'm happy. Okay, so now I can do my negation, so I'm just going to flip these around. So the point is, the only time it's correct to say neither A nor B is when you have A being false and you have B being false. Right? So that's the truth value of this statement. The only time it's ever true to say it's not the case that A or B is when you have neither A nor do you have B. And of course, and that is ultimately just going to be the same. Do I have the other one pre-made in here? Doesn't look like it. That's going to be the same as just saying A, B. Right? I'm going to come in here. I'm going to say, oh, well, not A. So first fill those. I'm going to come in here. I'm going to say not A depends on just A. So that's a true. Not B depends on B. That's true. True. False. False. True. All I'm doing is flipping the columns that I have over here. False. False. So over here, an and is only true when I have two trues. It's going to be false otherwise. Right? And this would make intuitive sense. That's exactly what the statement is saying. The only time it's ever true to say you don't have A and you don't have B is when neither A nor B are true. Right? And again, like, that's exactly what we just saw a second ago. We saw the same exact truth values. So all of this is what we call equivalence. This idea that two statements have the same exact truth value in the same exact places. And so the idea is, as we're thinking about these, we want to be thinking in some sense, right, that the truth value, like, that these statements are in some sense interchangeable, right, that they mean the same thing, that they're true in exactly the same worlds. Okay, this video is a little long, but we do have a couple other concepts to get to. It's an important one for us to really dig into and make sure we all know what's going on here. So the concepts I want to think about now are two more. Mutually exclusive, we're not going to spend as much time on this. This will pop up more as we go later. And entailment. So for the sake of time, I probably won't, well, here, so I just wanted to give you some clean examples to look at for mutual exclusivity. Again, we're going to be returning to mutual exclusivity and this sort of stuff more actually when we get to the end of the semester. It's a good idea just to put this in the old tool belt and have it in there, but these other two questions about equivalence and in a second entailment are going to be the important ones. But the point about mutual exclusivity, and I should say, you've probably also heard of this term before, so that's another reason why I think it's good to go over. You might have heard this and that are mutually exclusive. And the way we can think about that is just, are there any possible worlds where both of those two statements are true at the same time? So in this case, I've selected A and B, right? Just the idea that A is true and B is true. And then the statement not A and B. And the idea is, any time that one of these statements is true, the other one cannot be true, right? They can both be false, right? But they can't both be true. And that's what we mean by mutually exclusive, right? That if one is true, it makes the other one false. Okay, so it's not necessarily a negation, it's just to say that they can't both be true at the same time. So that's all that mutual exclusivity comes down to, is this idea that, well, if you have one, you couldn't have had the other. Maybe neither one of them happened, but we can't have both of them happening. Okay, so wanted to tell you about this, and we won't be spending as much time with mutual exclusivity. Really, though, the thing that we want to be thinking about is this idea of entailment. Because entailment is validity, right? Like, so actually I'll even... It's this idea that I could say, well, if these statements are true, then this other one has to be true, right? And that's what we mean by a valid argument. We want to find out, are there any cases where some statements, when we look through all the possible worlds and we look at all the worlds where where one set of statements is true, do we know that this other statement is true, right? When we look at all the possible worlds and see that all of our premises are true, are in any of those worlds, does the conclusion turn out to be false, right? Okay, so let's just go ahead and look at two simple examples right now, just to finish off today, and then we'll pick up with this entailment idea next time more in full. But the idea is that, right, with entailment and validity, that's what entailment is all about. We'll be using entailment and validity essentially interchangeably. Right? To say an argument is valid is the same thing to say its premises entail the conclusion. So let's see how that sort of thing will work, how we can analyze that with our truth tables. So I've copied and pasted two different truth tables here. Actually, let me fix this argument. To match, to represent these two different arguments. So let's focus on this one first. This argument says, premise 1, A entails B, right? That if A is true, B has to be true. Premise 2 says that A isn't actually true, and from that, the purported conclusion is, well, okay, then B isn't true either, right? It's like saying, well, A leads to B, but I don't have A, so that means I don't have B. And so what we want to do is we want to figure out, is this a good inference, right? Do those premises entail the conclusion? If we accept those premises, would we have to say the conclusion is true? So the idea is we want to look through each of our 4 possible worlds and try to find, is there any possible world, so I'll write this out, is there any possible world where the premises are all, as in both here, true, but the conclusion is false? That's what we want to ask right now. Are there any possible worlds where the premises are true, but the conclusion is false? So all I'm going to do is I'm going to say, okay, well, I've got my one premise, I've got my other premise. I've already filled out this truth table, right? It's pretty straightforward, right? I'm just doing my conditional and my negations. And now I just want to see, okay, so in world 1, I have one premise is true, and the second premise is also true, and the conclusion turns out to be true also. So, right, I'm happy there. Right? In the 4th world, we're just jumping around a little bit. My first premise is true, but my conclusion is false. But it's okay because my second premise is false, right? Like, I'm looking at this last world right here, right? What we're trying to ask is there any world where both premises are true and they entail the conclusion? If one of them turns out to be false, I don't care if the conclusion is true or not, right? Like, because then it wasn't about the premises, right, it doesn't matter. But notice, right here, this is a world where we have 2 true premises and a false conclusion. Right? This is what we call an invalidating row. It provides us with a counter example. So let me make this. Right? The idea is that we know there is a possible way that the world could go where the premises both turn out to be true, but the conclusion doesn't occur. This is what we mean by a counterexample, right? When we say that, hey, something is valid, we're saying anytime our premises are true, the conclusion has to be true. So a counterexample is a situation in which, no, I can show you your premises both can be true, but that doesn't mean your conclusion is true. And more specifically, I can tell you what that counterexample looks like, what that world looks like. I can say, well, suppose that A was false and B was true. If that happens, then the conditional is going to be true. Sure, A would lead to B. We're still going to say that's true, right? Just goes back to our rules up top. We're still going to say not A is true, but not B is definitely false, right? In this world where B is true, not B is false. So we would have a true premise 1, a true premise 2, but a false conclusion. That means believing these premises doesn't... Just because we know we're in a world with these premises being true, we still don't know, oh wait, is the conclusion true or is it false? Right? The point of a valid argument is that when we see the true premises, we should be guaranteed to know we're in that world, the conclusion is also going to be true. So, right, like, let's compare that over here. Right? So, to be clear, let me just make this painfully clear. Right? This is then, we call this an invalid argument then. None, and then let's just do... Right? Because it has this invalidating row. But look over here. Right? I'm again looking at all 4 of these combinations. I have a slightly different argument. Over here I said A leads to B, and I don't have A, so I don't have B. But over here I'm saying A leads to B, and I do have A. So doesn't that mean I do have B? Right? This is actually the same argument structure we spent so long in week 3 going over, right? This idea that A leads to B, and so if you do have A, you should get B. And back then we were just working with intuitions, but now we can see this more rigorously, why this sort of thing works out. Let's look at this. Let's try to see, under what circumstances are both of our premises true, right? In the first world, both of our premises are not true, so we don't care if the conclusion is true or not. Second world, both of our premises, right? Again, they're not both true, so I don't care if the conclusion is true or not. Third world, both of the premises aren't true, so I don't care about what happens with the conclusion. What I care about is, in this last world, or in any world, it just so happens to be just in this last world in this case, when both of my premises are true, is the conclusion guaranteed? So with this argument, in this truth table, we don't have any invalidating rows. We don't have any situation where both of our premises are true, but our conclusion is false. So, right, think about this with our definition of validity, right? We're trying to figure out, is it even possible for the premises to be true without the conclusion being true? If we can find a situation where, in fact, it is possible, right? If we can find a possible world where the premises really are true and the conclusion is false, we know, okay, cool. Those premises alone don't guarantee that I'm in a world where I have a true conclusion. But a valid argument is one where we can't find that invalidating row. No matter where we look, if the premises are both true, we see, boom, hey, the conclusion came for free. In other arguments, we might see multiple rows with true premises, but if it's a valid argument, the conclusion will always be true every time the premises are true. That's the whole point. if you can ever find a place where both your premises are true but your conclusion is false, then those alone haven't guaranteed that the conclusion is going to come along with the ride. Okay, so that is what, so let me go ahead and just copy. That is what entailment and validity is all about. It's about this question of, across all possible ways of thinking about things, across all possible worlds, is there any situation in which the premises can be true but the conclusion false? So I'm going to copy this, paste it here. So here, the answer was yes. We have a counter example. It's invalid. Over here, we would say, no, there's no way for the conclusion not to follow. Right? We're guaranteed to believe that conclusion based on those premises. And when I say that, right, like the idea is, if we could verify that we're living in a world where the premises are both true, boom, we would know, hey, we're living in a world where the conclusion is also true. All right, so that's the idea about validity and invalidity that we've been building to with these truth tables. The idea is the truth tables themselves allow us to spell out all of the different combinations and possibilities for the sentences. And when we have that, now we can see, okay, is it even possible for some statements to be true while others are false? And that's what allows us to decide, are some statements equivalent? Are some statements mutually exclusive? Are some statements entailed by other statements, etc.? And it's these relationships between our thinking, between our statements, that we want to really dig into. That's where we're thinking very critically about, right? When I believe one thing, what should I also believe as a result of that, or in connection with that? Okay, that's it for this video. I know it was already pretty long, but hopefully this has helped clear up some things, especially with that application. Let me know if you do have any questions. Definitely stay safe out there, and I will see you next time.